Good morning, students. In previous class, we have discussed the inverse Laplace transformation, various properties of the inverse Laplace transformation, and how to get the inverse Laplace transformation by using these properties. Today, we will discuss about some more problems relating to the inverse Laplace transformation. First, which is slightly different problem of the inverse Laplace transformation is you have to find the inverse Laplace transformation of 1 upon p square plus a square whole raised to 3 by 2 with respect to x. We have to find the inverse Laplace transformation of p square plus a square whole raised to 3 by 2 with respect to x. As we have calculated the Laplace transformation of the various functions, we see here that directly it is not the Laplace transformation of any function. Slightly different from the previous problems. First, we know that the Laplace transformation of z0x with respect to p. The Laplace transformation of z0ax with respect to p. This is the standard problem, and we know that the Laplace transformation of this one is 1 upon p square plus a square whole raised to 1 by 2. This is the Laplace transformation of z0x. Now, if we differentiate this one with respect to a, so we get d by dA of Laplace transformation of z0ax with respect to p is equals to d by dA of 1 upon p square plus a square whole raised to 1 by 2. In the left hand side, we see that the differentiation with respect to a, since a is independent of the Laplace transformation, or a is constant with respect to Laplace transformation, so the differential coefficient comes inside the Laplace transformation, and we get this as Laplace transformation of d by dA of z0 ax with respect to p. And the right hand side, when differentiate with respect to a, it will get minus a upon p square plus a square whole raised to 3 by 2. After differentiation with respect to a, we get this result. And if we differentiate it inside the Laplace transformation, we get it as Laplace transformation of j0ax with respect to a. This is nothing but x z0 dash ax with respect to p, and this is equals to minus a upon p square plus a square whole raised to 3 by 2. So we get the differentiation of j0x with respect to a, we get this result. Now, taking the inverse Laplace transformation on both the sides, taking inverse Laplace transformation on both the sides, we get x z0 dash ax, this is equals to minus a into inverse Laplace transformation of 1 upon p square plus a square whole raised to 3 by 2 with respect to x. By taking the inverse Laplace transformation, we get this result. So here we get the inverse Laplace transformation of 1 upon p square plus a square whole raised to 3 by 2 with respect to x is equals to minus x upon a z0 dash ax. And as we know that z0 dash ax is equals to minus of z1 ax. So this can be written as x upon a z1 ax as z0 dash ax is equals to minus j1 ax, which is the recurrence relation of the basic function. So here we get the Laplace transformation of 1 upon p square plus a square whole raised to 3 by 2 with respect to x, and this is equals to x upon a j1 ax, which is the required solution of this problem. This is very important problem, slightly different from the other problems of the inverse Laplace transformations. So this is the problem. Now we use another problem. We solve the another problem. We have to calculate the inverse Laplace transformation of 2p minus 1 upon p square plus 2p plus 29. P square plus 2p plus 29 with respect to x. We have to calculate the inverse Laplace transformation of 2p minus 1 upon p square plus 2p plus 29 with respect to x. We will use the various properties of the inverse Laplace transformation which we have discussed earlier. So the solution of this one is inverse Laplace transformation of the 2p minus 1 upon p square plus 2p plus 29 with respect to x. This can be written as the inverse Laplace transformation of 2p minus 1 upon p square plus 2p plus p square plus 4p. No, it is not 2p, rather it is 4p. It is 4p, sorry. It is 4p. So p square plus 4p plus 29, rather it is, with respect to x, and this can be written as inverse Laplace transformation of 2p minus 1 upon p plus 2 ka whole square, the whole square of p plus 2 plus 25 with respect to x. And we can write it as inverse Laplace transformation of 2p minus 4 2p plus 4 minus 5 upon p plus 2 whole square plus 25 with respect to x. Or we can write it as the inverse Laplace transformation of 2 into p plus 2 minus 5 upon p plus 2 whole square plus 25 with respect to x. Here we use the first shifting property. Which shows that if the Laplace transformation of fx with respect to p is equals to fp, or we can say that the inverse Laplace transformation of fp with respect to x is equals to fx. Then the inverse Laplace transformation of f of p minus a with respect to x is equals to e raised to ax f of x. The first shifting property, if we use this first shifting property, then the inverse Laplace transformation of this problem is equals to e raised to ax. E raised to ax, here a is equals to minus 2. So this is e raised to minus 2x 2p minus 5 upon p square plus 25, that is 5 square with respect to x. By using the first shifting property, this problem reduces to this one, or we can write this one as the e raised to minus 2x inverse Laplace trans 2 into inverse Laplace transformation p upon p square plus 5 square x minus 5 into inverse Laplace transformation of 1 upon p square plus 5 square with respect to x. By using the linearity property, this result can be obtained. Or we can write it as 2e raised to minus 2x. 2e raised to minus 2x. We know that the inverse Laplace transformation of p upon p square plus 5 square is nothing but cos 5x. Cos 5x minus 5e raised to minus 2x. The inverse Laplace transformation of 1 upon p square plus 5 square is nothing but 1 upon 5 into sine 5x. So this is 1 upon 5 sine 5x. So on solving this, we get twice of e raised to minus 2x cos 5x minus e raised to minus 2x sine 5x, which is the required result of the inverse Laplace transformation of this problem. So we have calculated some different type of the inverse Laplace transformations. Thank you very much.